Okay, so when we're using our deductive reasoning to prove angle relationships, we're actually going to skip over this first page because I'm assuming that not everybody has a ruler and protractor available to them. So we're actually going to jump ahead, because you're not going to have to be able to physically do it, to the second part. So it says, deductive reasoning involves taking known relationships to prove new relationships exist. In the last lesson, we used inductive reasoning to suggest the angle relationships with parallel lines. In this case, we're going to use deductive reasoning to prove it. So last time we just looked at measuring out the angles in those set cases. Now we're going to prove it definitively. So we are going to use these absolute facts that we already know are true. Angles on one side of a straight line are supplementary, which means they're going to add up to 180 degrees. Vertically opposite angles are always going to be equal. And if two parallel lines are intersected by a transversal, corresponding angles are also going to be equal. So, if I know that those three things are true, absolutely, then I'm going to prove alternate angles are also equal. So, angle 1 and 7 are alternate angles and create that Z shape. We need to prove that angle 1 is equal to angle 7. So the first statement we're going to make in completing this proof, or the steps, is angle 1 is equal to angle 3. Well, if I look here for angle 1 and angle 3, why do I know that those two are absolutely the same? Take a look at the three proven facts, and the answer is going to be because of fact number 2. They are vertically opposite. If I say that angle 3 is equal to angle 7, well, why do I know that angle 3 and angle 7 are the same? Because they are, looking at my answers here, corresponding angles. Or they make that F shape. Which means that if 7 is equal to 3 and 1 is equal to 3, then logically 1 has to be equal to 7. We refer to that as the transitive property. Both 1 and 7 are equal to 3, which means they also have to equal each other. And there we've proven it. If I take a look at another example of this, then it's saying complete the following two columns to prove that the co-interior angles are supplementary, which means that I just want to prove that the co-interior angles, in this case the ones we're using, are 1 and 4. We need to prove that they equal 180 degrees. So it started us off again. It's saying that angle 1 and angle 2 equal 180 degrees. Well, why do I know that these two equal 180 degrees? Because of the straight line rule. I know 100% it is true because of that straight line. And I could refer back to the previous page to prove that once again. If I said that angle 2 and angle 4 are the same, we just proved that in the last case. Why are they the same? Because they are alternate angles. Then, if 2 and 4 are the same, and 1 plus 2 is equal to 180, then I can replace, because 2 and 4 are the same, with my last statement. I can say that angle 1 plus angle 4 is going to equal 180. Because I said 2 and 4 are the same, so I just substituted in angle 4 for angle 2. Why is that? I can say that it's substitution. Because angle 2 is equal to angle 4. So I can substitute that one in. And as soon as I have proven that statement, I'm done. So I can definitively say co-interior angles are supplementary. And because we just use placeholders, where instead of using the actual value of the angles, we just used 1, which could represent any number or any angle, 4, 2, and 3, which could all represent any angle, and then used all that to prove that this is true, we know it's going to work in any case, no matter what it is. All right. I don't usually do this, but I want to do one more example with you, and we're going to go to assignment question 3. Just to carry this idea forward. So, first, we're going to take a look at this diagram, and it wants us to name 2 pairs of alternate angles. Well, the alternate angles, if I'm creating a Z shape, are going to be 1 and 4. Or I could use that reverse Z shape, which sort of looks like an S. And I can say that it's going to be angle 3 and angle 5. Now, it's given us a number of statements here. Complete the following 2-column proof to prove that the angle sum of a triangle is 180 degrees. So because the only triangle here is the one inside of here, then I need to state that angle 2 plus angle 4 plus angle 5 all have to add up to 180. So, the first thing I'm going to state is that angle 1, 2, and 3 add up to 180. Why is that? Because they make a straight line. Then, because we've already drawn the alternate angles, I know that 1 and 4 are going to be equal because they are alternate angles. I also know that 3 and 5 are going to be the same because they are alternate angles. And then all I've done is, in this equation, where I originally had the 1, 2, and 3, I replaced the 1 with 4 and the 3 with 5. And why could I do that? I used substitution. Since we've already proven that angle 1 is equal to angle 4 and angle 3 is equal to angle 5. So I just substituted the 1 with the 4 and the 3 with the 5 from my original equation, which means that that proves that angle 2 plus angle 4 plus angle 5, if it's equal to 1 and 2 and 3, we already know that that is 180 degrees. And there's our proof. The angle sum is 180 degrees. If we're using the results in B to complete the following two-column proof, to prove that the exterior angle of a triangle is equal to the sum of the interior opposite angles, then I need to remember that my exterior angle, which we can see here is 6, has to add up to the interior opposites, which would be the sum of 2 and 4. So angle 6 has to equal angle 2 plus angle 4. Well, we start with the final statement we had, the last case. Angle 2, 4, and 5 will equal 180 because the angle sum of a triangle. We know every triangle is going to add up to 180 now, so we can start with that. We know that angle 6 and angle 5 right here are going to add up to 180 because of the straight line rule. Which means that pulling from this statement, we can say that angle 2 plus angle 4 plus angle 5 would be the same as angle 6 plus angle 5 because they both add up to 180. And finally, if I subtract angle 5 from both sides, the equation is still going to balance out to angle 2 plus angle 4 is equal to angle 6. Because if I subtract the same value from both sides, the equation is still balancing. Which means that the exterior angle of a triangle equals the sum of the interior opposite angles.